Last time we have already discussed about a few things, measure of center and the measure of spread or measure of dispersion. As you all know, measure of center, that is measuring the center of the data, that is the measure of center, and the other measure is measuring the spread of the data, how it has been spread out, how it has been dispersed, right? How it has been expanded. So that is basically called as measure of dispersion, right? So these are some tools to measure the dispersion as well as to measure the centers. But we don't use all the tools for all the measurements. We mostly use certain tools. We will see that later, what tools that we quite often use in the statistical analysis. So we talked about dispersion, different types of dispersions are there. We took an example, then we did it. I hope all of you know how to calculate the variance, because the heart of the statistics is variance. So if there's no variance, no statistics at all. So that everybody should know how to calculate the variance, right? Each and every student in the class should know how to calculate the variance. At least you should know the principles. If you have a larger data, automatically we can use the softwares to calculate the variance. However, you should know what is happening, which divided by which. Sums of square divided by the degrees of freedom. So that is basically variance, right? So for a small data set, you should be able to calculate even manually and show how the variance could be calculated. Then we have the coefficient of variation. We took an example to talk about coefficient of variation. Coefficient of variation does not depend on the size of the object. We took an example of elephant and the ants. So that doesn't mean elephant has more covariance compared to the ants. So here we measure the covariance. That means among the elephants, what is the variation that they have? Among the ants, what is the variation that they have? So ants, we proved that ants have more variation than the elephants, right? Ants have more variations than the elephants. Right, today we are going to talk about a new topic that is based on the data. Again, it is called as displaying the data. How the data can be displayed. Data display, right? How the data can be displayed. The data can be displayed in different forms. The data can be displayed in different forms. I have listed down all the different forms of the data that can be displayed. Some of the forms that we are not going to cover in this particular course, and the others will have. Others we might have. Others we will go through in this particular course, right? Frequency, distribution, histograms, bar charts, stem and leaf display, box plot, line graphs, dot plots, right? So all these are used to display the data. Right, I will take, this has been already compiled. I will take height of 200 students in a class, right? Suppose in that particular class, we have 200 students in a simple form where I have measured the heights of all these 200 students, right? In that particular class. Now, this height has been measured in centimeters. The height measuring unit is centimeters. So I have measured the height of all these 200 students in centimeters. Clear? Right. After measuring, so how many data points do I have after measuring the heights of all these 200 students? How many data points do I have? Yeah. Arosha, yes. How many?
200.
Yes, 200. We have 200 data points, right? We have 200 data points. 200 data points with the units called centimeters, right? Now I am going to put this 200 data points in a table called as frequency table. This you have done in your O level maybe, just to recall it. Right, now I will later discuss with some of the format how this can be done. We have a table called as frequency table. This is the table called as frequency table. In the frequency table, there are some key features, key topics. First one is class interval. First one is class interval, right? First one is class interval. Second one is frequency, right? For the time being, we will look at those two, class interval and the frequency. In the class interval, we have, you see, 137 to 152 centimeters. So how many students are falling into this category of height 137 to 152 centimeter? So 25 students out of 200 students, 25 students falling into this category. That is 137 to 152. Then the 100 students falling into 152 to 167. 70 students falling into 167 to 182. And 4 students falling into 182 to 197, and 1 student falling into 197 to 212 centimeter, right? Actually, without giving problem to you all, I have already made a summarization into the table. So if you add all the frequencies, what should be the total number? The total number should be equal to the number of students that we have measured. So that is equal to 200. Okay, that is equal to 200. Right, now let's look at what is relative frequency. What is relative frequency? Right, so we need some information on that as well. So we have the first category, we have how many students? 25 students. The second category, we have 100 students. The third category, we have 70 students. In fourth category, we have 4 students. And the last category, we have 1 student. Altogether, we have 200. Right? So I'll just take it away. Now, these are the each category, right? So you have here class interval, different class intervals are there. We will see how to formulate different class interval in few minutes, right? So these are the frequencies. I will put it as F, the frequencies. So if you add all the frequencies, it should be equal to 200. Otherwise, something wrong. So the total number is 200. Now, the next category is called as relative frequency. Next category is called as relative frequency. What do you mean by relative frequency? Relative frequency is actually frequency of the event divided by total frequency. frequency of that event, or rather than we can call it as frequency of the class interval. I will put it as Ci to indicate the class interval. Frequency of that class interval divided by the total frequency. For example, in this case, 25 divided by 1. Right? We can give in terms of percentage, or we can give in terms of the decimal points. So, what is that frequency? What is that frequency? The first category? 0.125. What about the second category? 0.500. So likewise, you can calculate the frequency column. This is the column which indicate the frequency. Can you all hear? Can you all see the board clearly? I need the response.
Yes, sir.
Right, okay. So, relative frequency can be calculated as the frequency of that event or the class interval divided by the total frequency. Total frequency is 200 for a given example. Right? So, based on that, you can calculate the frequencies. So, we have calculated the frequency as such. So, this is the frequency of frequency. Just a second. Yeah, this is the frequency. So, we have calculated the frequencies individually. That is how the calculation takes place. Right? For the time being, we will just leave out these two tables, these two columns. Right? I will come to that later, little later after discussing. Okay? Right. Now, let's move to the other slide. I will come to that later. These two columns can be discussed little later. Less than relative frequency cumulative and greater than relative frequency cumulative. Right. Let's move to the other. How we can other topic, that is how we can discuss about the class interval. What is the system that we can use it? So I will make a note of it. For the first one, 137 to 152. Second one, 152 to 167. 167 to 182. Right, 182, 197, 197 to 200. Right, I just made a note of it. Then we will move to the other slide. Right. What are the steps that we can formulate to construct the frequency table? What are the steps? So these are some of the important steps that we are going to go through. First thing, not necessary to have equal class. Not necessary to have equal class. What do you mean by equal class? But if you have equal class, it is good. Can you tell about whether do we have in this example equal class? This is the class interval. What is the
every
interval
class
there?
interval?
Yeah, what is the interval there?
15, sir.
Yeah. What is the interval? The interval means difference between these two.
15.
15, yes. The interval is 15. What about this one? Second one?
15, sir.
15. Third one, 15. So here, what can we say Does it has equal class interval?
Yes.
Yeah, that is better. That is giving actual picture of the data, what it inside, right? So, but it is not necessary to have the equal interval. We can have any unequal interval also, but better to have a equal interval, right? Okay, so that is the first information. Second information is number of classes. How many classes do we have here? How many classes?
5, sir.
5 classes. 5 classes. This is the first one, second one, third one, fourth one, fifth one. So we can have 5 classes, for example, or depend on the data, we can have 10 classes or 15 classes. Not necessary to go on those numbers. We can have 7 classes or 8 classes or 12 classes. How we determine all these number of classes? That number of classes depends on how much observation that we have, right? How much observation that we have. So this is an example. So we'll have to have at least just 10 to 15 observation in each classes. That is the concept, right? If you have, let's say, 1,000 data, having 10 classes will not be a problem. We can have 10 classes. If you have 1,000 data, if you have 10,000 data, having 20 classes will not be a problem. No problem, right? So the classes, number of classes depends on the amount of data that we have. We cannot have, for example, if I have 10 data points, I cannot have 5 classes. Why? If you have only 10 data, I cannot have only 5 classes. Then we have a problem because each class will have only 1 or 2 data. That is not a good criteria.
The image cannot clear.
Yeah, not enough the number of observation for each category. So that is not a good criteria for constructing the frequency table. So to have a better frequency table, we'll have to have at least 10 to 15 number of data. So in this case, even if you go for 6 or 7 categories, that is fine, because I took an example 5 categories, 5 classes. So you can go for 7 classes, for example, or 8 classes. No harm, because this can divide further, right? Okay. So the number of classes depends on how much observation that you can see at once in one class. Right. Number of classes, neither high nor low. So that we'll have to remember. You cannot have a high number of classes, or you cannot have a small number of classes. So the number of classes has to be in the range of usually 5 to 15 classes. Right? Usually 5 to 15 classes. Again, it depends on number of data. And size of the class interval. This is what I talked about. Here we have the size of the class interval. This is 15. In our example, 15. We can have 10, for example. If we have 10, we can have roughly about 7 or 8 classes. Right? If we have 10 as an interval, we can have 7 or 8 classes possible. Right? So likewise, the size of the class interval also usually we have 5, 10, 15, 20 for easy calculations. Right? Right. Now, when you construct this class interval, class, this is called as class. Right? When you construct this class, we have some limitations. Right? What are those limitations? First one is called as overlapping class or exclusive class. Our example is it an overlapping class. There are 2 types, overlapping class or exclusive, that is one category. The other category is inclusive or non-overlapping classes. Can you tell me whether this is overlapping or non-overlapping class?
Non-overlapping.
Look at the data very carefully. What is the difference between with the example? Look at very carefully.
Overlapping class.
Overlapping, sir.
Yeah, it is an overlapping class. I will just. What do you mean by overlapping and non-overlapping? Let's say I have 110 to 120, 120 to 130, 130 to 140. Right. This is one type of example. The other type of example is 110 to 190, 120 to 129, 130 to 139. Look at these two differences. Look at, can you all see this? Can you all see the board?
Yes. Yes, sir.
Yes. Right. Look at, are these same?
No.
No. This is overlapping class. This is called as overlapping. This is non-overlapping. There is no harm whether we formulate overlapping or non-overlapping. Both will give the same results. I will show you. Both will give the same results. Whether it is overlapping and non-overlapping. Right? Suppose, let's say, I have a value 150. I have a value 150. Where do you put in the overlapping class? In this class or this class or this class?
In first class, sir.
Yeah, this is first, second, let's say third. So I will put it in first class because 150 is falling here. What about the second category? Non-overlapping?
Here also first class, sir.
Yeah, that is also, we can put it in first class, no problem. So this is another problem. Right, 190. 190. Where can we put in the first category? First class or second class?
First class.
First class. What about in second?
Yeah, also first class.
Yeah?
First class.
Yes, first class. Right. Now we will come to a stage. I have 119.4. 119.4. Where can we put this? Look at the definition, 119.4.
119.4, sir. In first group, we can add in the first class.
Yeah.
But the second group, there is a exclusive. That is, that can't we cannot put any data
Why?
because the range is 10 to 19, 20 to 29. The 19.4 is exclusive values.
Yeah, 19.4, because we don't have any decimal points here. So what is, where we can put 19.4? Where can we put? Is it under 119 or 120?
190.
190. So, isn't it? Because no decimal points are given here. So 119.4 is 190. No problem. So now you see 119.4, we can put it here. Similarly, 19.4, it is automatically coming into the first category. What about here? In this case also it is coming here. right? Why? The closest value is 190. Right, now let's take another example. 119.6. 119.6.
It's commander second group.
Yeah, now you see it is coming under the second category here. Why? Because the approximate value is 120. The approximate value is 120. Isn't it? The approximate value is 120. So it is coming under this category. Whereas here also it is coming under that category. No difference. So whether it is overlapping or non-overlapping is not a matter. It's not a matter. It's matter how you follow the rules to put them into different categories. The matter is how you are classifying them to put into the categories. Whether it is a non-overlapping or overlapping will not work. So as we said already, when you talk about overlapping or non-overlapping, so you'll have to follow the rule. So what is the rule here in the overlapping? In this case, any value above or equal 110, above or equal 110 will takes place. For example, let's take 120 to 130. In our example, it is given. So any value of 120 equal to 120 or above 120, but less than 130. Any value equal to 120 and above 120, but less than 130. So that is basically the concept of overlapping classes. So we can have overlapping or non-overlapping classes as we want. Right? Right. Now, I would like to introduce the fourth column, that is less than relative frequency cumulative and greater than relative frequency cumulative. Less than relative frequency cumulative and greater than relative frequency cumulative. So first one is less than, right? Before that, we look at the frequencies, relative frequencies. So this is 0.125, 0.500, 0.350, 0.020, this 0.005. Right, now I have simply written down what is appearing on the screen. So these are relative frequencies. If you add all the frequencies, relative frequencies, it should be equal to 1. It should be equal to 1. Right? Okay. Right. Let's look at less than relative frequency. How does it work? I will put it as less than relative frequency. So simply it is the frequency of the first category. Then add the frequency with the second category. So that is 0.625. Then add with the third category. That is 0.975. Then add with that is 0.995. Then add with that, which is equal. So that is called, I will show you why we want to have less than relative frequency. So greater than the other category, greater than relative frequency, other category is starting from 1. You see, it is starting from 1 and try to get rid of 1 by 1, starting from 1, right? So this is greater than relative frequency. Let's say starting from 1. 1 minus this. So 1 minus that is 0.875. Then this minus that. That is 0. What is that? 2, 5, 0. Is it? 250. Right? Yeah, 250. Is it correct? Sorry. Not this one. Huh? Deduct that one. Not this one, because it is depend on relative frequency. So in this case, this and this is same, so no problem with that. So this is fine. So this minus that is 0.3. So fine. This minus this 0.075. No, not 75. 25. Okay. That minus this frequency, that is 0.005. Is it clear how this greater than coming into picture? Understandable? Yes? Is it understandable how the greater than relative frequency, less than relative frequency, this is greater than relative frequency, right? Okay. Any questions? So we started from the total total relative frequency is 1. So 1 minus this relative frequency, that is here. Then 0.875 minus 0.5, 0.375 minus 0.35, right? 0.025 minus 0.020. Then this is the last point. Okay? Clear? Any questions? Yeah? Understood? Sadika? Did you understand what is this less than and greater than relative frequency? Sadika, are you around? Sadika? Suganya? Did you understand? People are sleeping after heavy lunch.
Yes, sir.
Yeah.
Yes.
So you'll have to reply. Otherwise, I don't know whether you all understood the fact, right? Right. So this is not very difficult to calculate less than, greater than, relative frequency. I will show you why I did calculate the less than and the relative, greater than relative frequencies. First of all, let's look at the rest of the items where I can draw the class interval versus frequency, or class interval versus relative frequency. I can draw some of the graph. So this is called as bar chart. You will learn in Excel how to draw these kind of bar charts. So bar charts, look at the x-axis. Look at the x-axis. It is giving, I mean class interval, right? Class interval, we have different class interval. You see, different class interval. For different class interval, it is giving the frequency. What is frequency? That is the total number of observations coming under the each category. So here it is roughly 25. This is 100, right? And so on. Right. So this is the frequency versus class interval versus frequency. Similarly, we can have class interval versus relative frequency. I have simply put RF, relative frequency. Class interval versus relative frequency. That is also possible. You see, is there any difference between these two graphs in terms of nature? Any difference between these two? Can you show me any difference? Only the scales are different. If you look at the structure of the graph, in both cases, all are same. So you see, the structure of the graph is almost same, right? Structure of the graph is same. So whether you draw class interval versus frequency or class interval versus relative frequency, doesn't matter. It will give almost same features, right? Right. That is that we can draw bar chart. Right. Now this is more important. We call it as ogives. Can you remember we took the last two columns, less than relative frequencies and greater than relative frequencies, right? Less than relative frequency and greater than relative frequency. So what is if you draw the class interval versus those relative frequencies? So here class interval versus less than relative frequency cumulative. I have simply put less than relative frequency cumulative. So this is class interval versus greater than relative frequency cumulative. The same thing that appearing on the table, we have drawn it. So it's look like this. Normally, this graph is generally, it's like this. In generally, this is the cumulative density function we will talk about later. The cumulative density is that is how it's operated. Less than relative frequency cumulative. This is greater than relative frequency cumulative. This is nicely coming down. So these are typical types of graphs. So these are having special name. It is called as ogives. So those are called as ogives. We call these less than ogive and greater than ogive. Right? These two are called as less than ogive and greater than ogive. Okay. So if it is less than ogive, you should know how to draw it. If it is greater than ogive, you should know how to draw it. So simply, it's the conversion of what we have seen on the table into a graphic form. Right. What is the use of this? What is the use of this ogives? What is the use of this ogives? Anyone? So what is the total number of students in this class?
200.
Total number of students in this class?
200 students.
200. Now my question is, what is the proportion of the students? What is the proportion of students? Let's say that is the variable x, height of these students, having greater than 182, greater than or equal 182 centimeter in height. What is the proportion of students having height greater than or equal to 182 centimeter? What is the answer?
0.025.
Yeah, 0.025. You see, how did we get the answer? actually to see that, so greater than probabilities, this is probability, we will talk about probability later, right? What is the probability or the proportion of the students who are having height greater than or equal 182 centimeters? For that, we have to look at the relative frequency of greater than relative frequency cumulative. So if you look at that, because any value, you see any class value beyond this, if you measure any class values of height above this, okay, so that means 182 and above. So what is the number of people? This is the number of frequencies. This is the total frequency of these two. So that reflects here under the greater than relative frequency situation. Right. I can ask a similar kind of question. Probability of x less than, let's say, 167. Less than or equal 167. What is that?
0.625.
Yeah. So for that, for less than situation, we can use less than relative frequency. So if you look at less than 167 centimeter, so we are talking about any value beyond this, any value beyond that, right? 167 and lower value. So that to see that, we can see the category of that. This is the answer. So this is the usefulness of having these two tables. In this case, we have a small number of classes. Number of classes is only 5. So easily we can identify. But if you have 10 classes, 15 classes, difficult to calculate all these, right? So we can find out the less than and greater than values using these less than and greater than relative frequency cumulative. Okay. Any questions? Any questions? Right? Any questions? Right. This we can put it in pie chart also. You will learn how to draw all these bar chart, pie chart in your practical. There's a small practical component also. You will learn. I think either Mr. Vernagoban or the other computer instructor will teach you how to do all this by using computers, right? Right. The second one is pie chart. This is another graphical display of data. This we can do a lot of work. We can get in percentage as well because these have been given in numbers. Sorry. These have been given in numbers. 125 is red color in this range, right? Blue color is this numbers 25. If you want, you can request to give in percentage. It will give number and percentage. So a lot of options are there. You can request, right? So let's say if you have different categories, families, right? We can different categories. For example, bar charts and pie charts could be used to distinguish different categories. Which category is higher, which category is lower, and so on. Right? Just a graph. Right. Now we will come to the other topic, which is called as stem and leaf. All right. I will use the board Any questions on this frequency distribution? Any questions? Yeah. Right. Now, next topic is stem and leaf. That is another way of displaying the data. Stem and leaf. Right. So, if you have a data, let's say I have 15, value 15. The first digit is called as stem. The second digit is called as leaf. Stem and leaf. Look at this. 112. So this is called as stem. This is called as leaf. 121.5. So this is called as stem. This is called as leaf. So this 12 is called as stem, right? $121.5. So this 12 is called as stem. 1.5 is called as leaf. So stem and leaf. All right? Is it clear? Tanupriya, is it clear? Tanupriya, are you around? Yeah. Right. You see here the first number is 10. Right. You have the first number is 10. So the first digit, this is stem. This is leaf. So the second value is 12.5. This 1 is stem. 2.5 is leaf. 112. This 11 is stem and 2 is leaf. Right? I will have to name some of the people, otherwise you all are sleeping. Huh? Randomly I will select a person. Imasha, are you around?
Yes, sir.
Yeah, 59. Did you understand this stem and leaf?
Yes, sir.
Yeah, right. So let's say 135.5. What is stem? What is leaf?
13 stem,
Yeah.
5.5 leaf.
Good, good. Right, fine. Right. Now, let's say we have a set of data. We have a set of data here. Right? We have set of data. I think all of you have this data. Now we are going to put it into stem and leaf. First, look at what is the lowest value and what is the highest value. What is the lowest value?
6.
6. What is the highest value?
37.
37. So you see, for 6, what is the stem? What is the leaf?
Stem 0.
Yeah, stem
Leaf
0,
6.
leaf 6. So you see, first we'll have to identify the data and put them in ascending or descending order. Right? Put them in ascending or descending order. So after that only it is easy for us to put them in stem and leaf. So this is the first data, 6. So that is this is the stem. So that is the leaf. Leaf is 6. What is the second data? 9. Second lowest data. Right? So for 9, what is the stem? What is the leaf? Stem
0,
is,
9.
yeah,
Stem
0
is
is the stem, 9 is leaf. So 6 and 9, which is coming as a stem of 0. So likewise, we can put all the values into stem and leaf. Right? Okay. Somebody's phone is working. Mute it, mute it. Right? So this is the stem for the another set of data, which is 1 is the stem. So this is 12, again 12, 14, 14, 14, 15, 16, 18, 18, 18, 18, 19, 19, and so on. So this is how we organize the stem and leaf. Is it clear? Is it clear how to organize the data? So this is the total set of data where we have organized that into this format, stem and leaf, in simple format. Okay. Right. Second category is called as double stem and leaf. Double stem and leaf. Right. What is a double stem and leaf? So double stem and leaf. Look at here. So how many stems are there on the same value? One is repeated here, isn't it? 2 is repeated. So double stem. Earlier it is a single stem. Now it is a double stem. What do you mean by double stem? So here from value 10 to 14 will be accepted. All the value from 10 to 14 will be accepted in first stem. Then 15 to 19 will be accepted in the second step. So it has been split. So how many data coming here? Possible data? 10, 11, 12, 13, 14. 5 numbers will accommodate. Here 15, 16, 17, 18, 19. Again 5 numbers. Equally it has been divided. So can you tell what are the numbers can be accommodated in the first category of 2? 22, 24. Right? Here it is 25 to 29. So I will take an example, right? I will take an example. Let's say I have 15, 13, 22, 28. Can you tell where this 15 comes? 15 coming here. What about 13? 13 coming there. 1, 3, 13. 15 is the second category. 22 coming here. 28 coming there. You see? So it has been, again, the single stem has been split into 2. So, okay? All right? So that is called as double stem and leaf. So you see here, right? You could have put, this is also double stem, but I didn't put it there, right? 2 zeros can be accommodated, 0, 0, isn't it? But in, I didn't put in the first 0 category, how many observations are coming? For the same data, how many observations are coming in the first 0 category?
2.
No. I'm asking here 0, here also 0. Double stem, don't forget that. Stem is splitted into 2. So here 1,
1
here
to
2. How many data coming into this 0? How many data points are there? Less than 4.
4.
How many data points are there? Less than 4.
4.
Huh?
4, sir.
I couldn't hear. Yeah, Vidhu?
4, sir.
No, I'm asking again the same example, early example. How many data points coming under this category? This category. How many data
No
points?
data.
No data. Yes. Why? Because this accommodate only from 0. That means 1, 2.
There is no any data, sir.
No any data there. So that's why I didn't include that. No any data because our data starting, the lowest data starting from 6. So 6 is coming in the second category. 9 is also coming under the second category, the second step of 0. Look at this. This is 2 step. 1 and 1. So 12, 13, 14. Up to 14, we can accommodate in this category. Above 14, that means 15 up to 19, starting from 15 up to 19, we cannot accommodate here, we'll have to accommodate there. Similarly, 20 up to 24, we can accommodate there. Then 25 to 29 in the second stem of 2. So likewise, this is called as double stem and, right? Double stem and leaf. Right? Single stem, double stem. Because it depends on number of data. If you have 10,000, 15,000 data, just putting into single stem and leaf will not work. Let's say marks of A-level students sat for physics in 2019. How many students sat for A-level of physics? More than 75 students. So what is the range of the marks? What is the possible range of the marks? Possible range. 0 to 1000. What is the possible range of marks?
0 to 100.
0 to 100. Yeah, so the marks is spread only from 0 to 100. So we'll have to accommodate all 75,000 from 0 to 100. So having more categories better or having only one category for each step? I mean, double stem is better or single stem is better in this example?
Double stem.
Double stem is better. Why? You can see more spread. Actually, double stem also not enough. We'll have to go for
5
more
stem.
stem, 5 stem. What do you mean by 5 stem? You have 1, 1,
Split
1,
the data.
5 times. So in this first one, what are the observation accommodated? 0 and 1. That means 10 and 11 accommodated there. What about in second category?
2 and 3.
2 and 3 accommodated there. What about fourth category? Sorry, third category? 4 and 5. Then fifth category, 6 and 7. And the last category, 8 and 9. You understand? So this is called as 5 stem and leaf. So if you have such a huge data, as I pointed out earlier, 75,000 students, marks have to be entered. We'll have to see the spread, how it has been spread. So for in that case, rather than going for single or double, 5 stem and leaf would be better. Right? Okay. Right. Now, tell me, this is stem and leaf, right? We are talking about stem and leaf. The other one is, what is that? Frequency table. Frequency table and stem and leaf. Right? Which one is superior? Which is superior? Stem and leaf?
Stem and leaves.
Frequency. Yeah?
Stem and leaves, sir.
Why?
Because that we can show all of the single data.
Yeah, good, good. In the frequency, look at this. Look at the frequency. Once you have entered all the data, because we have students of height students of 200 in the class, we have entered all the data into the frequency form. So all the data has been entered in the frequency form. So once you, if you have only this table, can you go back to the original data? Will it possible to take the original data from this frequency? Yes or no?
No.
Huh?
No.
Yes, you cannot pull back the original data. That is the disadvantage of this frequency table. But what about the stem and leaf? Stem and leaf.
We can go back.
Stem and leaf, you see, this data is remaining. Even if your original data is not there, you can still use this stem and leaf to extract the original data, right? So we can extract the original data, like first one is 6, second one is 9, third one is 12, right? 12, how many times? 2 times. 12, then 14, 3 times, right? I can construct the set of original data without any problem. Do you understand? So by looking at the stem and leaf, I can reconstruct my original data. This is my original data. But in frequency table, where you cannot do that. So that is the biggest problem in frequency table. So the other thing is, let's say this is the stem and leaf table. If you turn this stem and leaf table by 90 degree onto the left, 90 degree onto the left. So you will have stem here. I'll put it as S. Stem here starting from 0, 1, 1, 2, etc., etc., right? 2, etc. So you will have numbers here. First number here, the second number, right? So if you turn this by 90 degrees, it will give actually looks like a frequency table, right? It's give a kind of frequency table. So that is the advantage of this stem and leaf. So what we say is in this stem and leaf, we don't lose the original data as we do in frequency table. So that is the advantage of having stem and leaf. Clear? Is it clear? Is it clear? Rania, Nagaraja, are you wrong?
Yes, sir.
How about the clearness? Do you understand?
Yes, sir.
Right. Okay, fine. Right. The other display of data, some of the data display called as percentile. Percentile. It is simply giving the percentage. Those are the values which can say the percentage of the values, right? For example, 10th percentile. 10th percentile mean if you have data, 10th percentile mean, let's say you have 100% data, 10th percentile mean 10% of the data on your left side and 90% of the data on your right. 10 percentile mean 10% of the data on your left side, 90% of the data on your right side. So that is called as percentile. So we can have a percentile in different forms, maybe 50th percentile, 60th percentile, and so on, right? So 50th percentile, what does it mean, 50th percentile? It is splitting the data into two halves, isn't it? So what is the another name for that? 50th percentile. Here 50% of the data on your left and another 50% on your right. So how do you call this 50th percentile? It is median, isn't it? It is median, right? 50th percentile is actually the median. Similarly, there are other display of data, deciles, right? So second decile mean it is splitting the data into 10 equal portions, right? Second decile mean you are splitting the data into second decile, right? So it's splitting the data into two, where the left side is roughly about 20%, the right side is 80%. This is called as second decile. Okay. Right. Right. Is it clear? Percentile and decile? Yes? Is it clear? Pubudu, are you around?
Yes, sir.
Yes, Pubudu. How many Pubudus are there? Only one or two? Pubudu Jayapatma. Jayapatma. Herath Mudliansige Pubudu Jayapatma. Who is that? Mr. Pubudu? Pubudu. Herath Pubudu. Where are you? You came and left. Jayapatma Pubudu. Where are you? Hmm? Mafra. Are you around, Mafra? Mafra, Fatima Mafra, missing. AG 071. Kajendini? Selvarasa? Kajendini Selvarasa? No? It's look like no one is around. Huh? Let's look at how many of you are there. Kumari 074.
Yes, sir.
Can you tell me if I say fifth decile, what does it mean? If I say fifth decile,
5 out of 10.
yeah, 5 out of 10. What does it mean according to my explanation? What is 5 out of 10? But in percentage, what is that?
5%.
Once again,
50%.
yes, 50%. So it will split the data 50% left side. So if it is 50% left side, what is the percentage on right side?
50%.
Again 50%. So this fifth decile can be renamed with another name. Can you tell me what it is? Where the data can be split into two exact halves. Just now I mentioned about it.
Median.
Median, not median, median. Yes, fine, good, Kumari. Right. So percentile, deciles are some of the other types of displaying the data. Another displaying data type is called as quartiles. Quartile. What do you mean by quartile? Quartile. What do you mean by quartile? Without looking at the notes, you can tell what is quarter. Quarter means what? Anyone? Quarter mean? Quarter mean?
1/4.
1/4. Yes, good. Quarter mean 1/4. So here we try to split the data based on the quartiles, right? So we split the data into different quarters with different names, right? So let's say if I have 100% data saying from here to here, right? So this is called as Q1. In your notes, how does it say? Q1. What is Q1? Quartile 1. Quartile 1, splitting data into two, where 25% on your left, the rest 75% on your right. So this is quartile 1, Q1. Q2, it's splitting data into two, where the left side is 50%. So if left side is 50%, what about right side? Yes, 50%. Again, right side 50%. That is Q2, quartile 2. What about third one? Q3, third quartile. This is first quartile, second quartile, this is the third quartile. So third quartile, dividing data into two again. So that dividing where left side is 75%. If it is 75% left side, what is on your right side? What is the percentage?
25.
25%. Yes. 25% on your right. Can you tell me there's a specialty with Q2? What is Q2? We can rename Q2 with another name.
Median.
Median, yes. Q2 is a median, right? So we'll go back to the slide. The same thing which has been explained. The first quartile, which is called as Q1, 25% left and 75% right. Second quartile, 50% and 50% left and right. And the third quartile, 75% left and the 25% on right. So median can be renamed as 50th percentile or 5th decile or second quartile, right? Median can be renamed as 50th percentile, 5th decile and second quartile. Okay. Right. Now let's consider the data. Have you all got the notes of this lecture? Yes or no? Have you got notes of these lectures? Jeffrey,
Yes, sir.
have you all got the notes of this lecture?
Yes, sir.
Huh?
Yes.
Yes or no? There should be only two answers, either no or yes.
Observing, sir.
Huh?
Observing, sir. No.
No, I'm asking. Have you all got the notes of this? I have already uploaded this.
Yes, sir.
Huh? Have you all got it? I want to see whether you all have received it. Have you all got the copy of these notes? Jeffrey, any idea?
Already watched the. Already I got. I already watched these slides in LMS, but I didn't get the photocopy.
Why? Why? Because our purpose is to give the material well before the lectures, so that you can read and come prepared for the lectures. That is the purpose. No point of otherwise. If others, I mean, this is for all of you who have not looked upon the notes. Otherwise, I will start doing the second part of the lectures without giving the notes. Is it okay? Because this is, I prepared all these notes because of you all, because of this LMS. Usually, I don't use PowerPoint for statistics. So, the main purpose is not fulfilled. If you all are not with the notes, just looking at the board and having fun, that cannot be done. You can do with any other classes, but not with my class, right? So I usually send well in advance all this information, right? To facilitate you all with what I teach. But ultimately, if you all are not going through the notes, so if you don't have a set of notes in your hand, so what you are going to do? Huh? Right. How many of you have problem accessing to the notes? I think all of you have got the notes. Anyone doesn't have a set of notes? Yeah. So thereafter, don't blame me. So this is, this is a new subject that you all are learning. Even though I am giving very slowly all these lectures, maybe later on very difficult to understand part of it, but not difficult, but people think that they have difficulties in identifying and following the lectures. So don't mess up things, right? Okay, Jeffrey, inform
Okay,
all
sir.
the students.
Okay, sir.
Inform all the students to have a copy ready during my lectures. so that
Okay,
they can write the additional notes or information, whatever they want. Otherwise, no point, right? Right. Set of data has been given, right? 14, 15, 16. Don't worry about what sort of data. So the data has been given. How many data points are there? How many data points are there? Anyone?
Thirty-two.
20?
32.
32. Fine. Okay, thanks for sending the message that all of you are having notes. That is what I want to find out, because I thought some of you have missed out the notes. If you don't have notes, you will have problem, right? So good that everybody has the notes. Keep the notes with you. Have a print and not in the computer or not in the WhatsApp or Viber. You take a printout and keep it with you. Whenever I discuss, you can incorporate some of the additional information. Otherwise, otherwise, later on, if you look at the notes, தமிழ்ல சொல்றது நோட்ஸை பார்க்க போனால் சிதம்பர சக்கரத்தை பே பார்த்த மாதிரி இருக்கு. සිංහලෙන් කියනවා නම් නෝට් එක අන්තිමට ගත්ත ගමන් නෝට් එක කියවනකොට කොහේ යන්නේ කියලා ප්‍රශ්නයක් ආපු ගමන් මල්ලේ පොල් කියලා උත්තරයක් දෙන්න වෙනවා. Right? So better to avoid all these things. Be prepared. Have a notes with you always. Right? Maybe there may be slight changes because time to time I may update it with the notes, but keep the notes always ready with you all, right? Okay, right, fine. So these are the data set that we have. Somebody said 32 number of observations are there. Fine, I didn't count it. Fine. For these data, 25th percentile, Q1 is 70. Value for the Q1 is 70. We can find out. What is this Q1? What is Q1? Q1 means quartile 1. It split the data into 25% left and 75% on right. Right? So that is called as Q1. So the value is 70. How to find out this value? Let's look at it. The 50th percentile is 90, and the 75th percentile, that is Q3, is 20. How to find out all these values? Since the data points are less number, we can find out very easily here. But if the data is a very large data set, 1,000 or 20,000 or 30,000 data, then very difficult to find out manually. We have to do it by computer. Right. For that, you need to have some formula. Quartile location. It is called as quartile location. So this quartile location is given as truncated median location divided by 2. I will explain what is this truncated median location. Truncated median location divided by 2 plus 1. Right? Actually, this plus 1 has to come here. Huh? Something wrong here. So the truncated median location plus 1. Huh? Change this notes. This is wrong. Huh? This plus 1 has to come there. Right? Change the notes as plus 1 has to be come on the top. That is coming as a numerator. truncated median location plus 1 divided by 2. Clear? So this is wrong, right? Right. Now, somebody said 32 set of data. Is it 31 or 32? This data? 31 or 32? Can somebody cross check it? So median location, right? What is median location? Yeah, 31 data set as there. Median location we learned already. That is normally n plus 1 divided by 2. That is the total number of observation plus 1 divided by 2. Median location. Can you remember that? That is the time when we talk about median, we discuss about that. So median location is n plus 1 divided by 2. So n is 31 plus 1 divided by 2, that is 60. Right? Right. Now, what is the truncated median location? Median location is 16. In our example, I will just show you. Median location is n plus 1 divided by 2, which is 31 plus 1 divided by 2. So that is 60. Okay, no problem. So this is called as median location. Right? In our quartile location formula, we talked about truncated median location. What do you mean by truncated? Let's look at another example. I have a data set of 32. I have a data set of 32 in another example. So in that case, my median location is n plus 1 divided by 2. What is my n? 32 plus 1 divided by 2. So now my median location is 16.5. My new median location for this data is 16.5. So this is the median location. We can't use the median location directly here. Why? Because it is with decimal points. So I am truncating this decimal point. That is called as truncating, using this 16 as the truncated median location. So this is called as the 16 in this example is called as truncated median location. Here nothing to truncate. Why? Already it is a full digit number. This is a 16 is a full digit number, no decimal points. So full digit number, no problem at all in truncating. So we can use as a 16. But in this case, 16.5, we remove this decimal point, not taking the approximate value, then you will be in wrong. Will be wrong. If you take approximate value, this become as 70. That is not the way. Truncate mean you cut down. Trunk mean remove. Trunk mean it is truncate mean remove, right? So truncate mean remove. So remove your decimal point. Use that truncated median location as for the calculation. So you see there. So in this case, we don't have problem by the median location is directly a full digit number. We don't have problem. So it has been put directly there, nothing to truncate. Right? So now the quartile location definition, based on this definition, truncated median location plus 1 divided by 2. This is wrong, huh? Divided by 2. So 16 plus 1 divided by 2, which is 8.5. So now you see, what do you mean by this 8.5? That means if you have a set of data, let's say if you have a set of data, let's say this is Q1, Q2, Q3. After putting into ascending or descending order. So this is 25%. This area is 25%. This area is 25%. This area is 25%, and this area is 25%. Okay. Rather than saying area, the data consists 25% of the data, 25% of the data here, 25% of the data, and 25% of the data. Right. The quartile location says 8.5. So that means after putting all these data into ascending or descending order, let's say we are putting them into ascending order, then your first quartile, let's say Q1, will be located between 8th position and the 9th position of the data, in between 8 and 9. Why? We are having a decimal point here, 8.5. So your Q1 is in between 8 and 9 position after put them into ascending order. So Q1 and Q3, because this is Q1, this is Q3. So this Q1 and Q3 will be located between 8th and 9th observation, forward and backward. So here in between 8 and 9 position, 8 and 9 position from the forward will be Q1. Q3 will be 8th and 9th position from the backward. 8th and the 9th position from the backward. So that is how we find out the Q1 and the Q3. Is it clear? Q1 and Q3 can be found out easily. So how explain? So I said here Q1 and Q3 can be found out easily using the same example. Let's say this is the whole data, this Q1, this Q2, this Q3, right? So if you go from here, Q1 will be in between 8th and the 9th position of the data from the forward. Q3 will be between 8th and the 9th position from the data of backwards after putting the data into ascending or descending order. Right? Right. Okay. Right. So Q1, Q3 we can find out backward and forward. Right. Now this is called as box plot. Right? Box plot. That is one of the way to explain the data. Can you remember when we discuss data display today? One of the technique is box plot. Look at one of the technique is box plot. Frequency, pie chart, bar chart, histogram. Then this is called as box plot. Box plot is actually explaining only Q1, Q2, and Q3. What do you mean by Q1, Q2, and Q3? What do you mean Q1, Q2, and Q3? How do you call that? Kajendini, are you around? Kajendini, are you around? Kajendini is missing. Huh? Kajendini, are you around? What about Latsika?
Yes, sir.
Yes. Can you tell me, Latsika, what is this Q1, Q2, Q3?
Quartile 1, quartile 2, quartile 3.
Right. What do you mean by this Q1? If you take a data, if I find the value for
Left
Q1,
side 25%.
yeah,
Left side
yeah,
25% and right side to 75%.
right, good. So Q3 mean, for example, left side 75%, right side,
Right side 25%.
good, good. Okay, right. Now, in our previous example, we have found out Q1, Q2, Q3. I will take a data set later on. I will show you how to find out. Even we can do it, you can do it as a homework. Find out Q1, Q2, and Q3. Check, I mean, I have already found out. Check whether these values are correct, right? So Q1, Q2, and Q3 values have been given, 17, 19, and 20. Now, what I'm going to do is, I'm going to draw according to the scale. You all are expert in drawings, right? Engineering drawings, have you done in your first year? Yes or no? Jeffrey, have you all done engineering practicals, drawings? Yes, right?
Yes, sir.
All right. So, you know what is drawing on scale? So, for example, in this box plot, where I have drawn according to the scale, 17, right? 19 and 20. What is this 17, 19, and 20? These are Q1, Q2, and Q3, right? Now look at this box plot. This is called as box plot. Box plot is constructed only using this Q1, Q2, and Q3. Can you comment on this Q1, Q2, Q3? What is the percentage of data incorporated into this box? What is the percentage of data coming into this box? According to our calculation, what is the percentage of data coming into this box?
75%.
Check. I mean, I'm talking only the box. What is the percentage? What is the percentage of data coming?
50.
50%. Yes, correct. Why it is 50%? Because we said Q1, if you demarcate Q1, left side is 25%. If you demarcate Q3, right side is 25%. So left side and right side, that 25% has missed out. So what is in the middle? 50%, right? For example, let's say this range cover 25% of the data. This range is covering another 25% of the data. So again, we have 25% on your right side, and here another 25%. We don't know those, right? We don't know those. That is, we don't know these two. So what is trapped in the data is only 50% of the data. So can we write like this? This is the total data that we are talking about. Box plot explains the middle 50% of the data. Is that statement correct? Why middle 50% of the data? 25% on left and 25% on the right, left over. So that we are talking about only 50% of the data in the middle. Do you agree with that? Yes or no? Yes. Oh no. Sandanika, are you around?
Yes,
Sandanika?
sir.
Yes. Whether that statement is correct, box plot explain middle 50% of the data.
Yes, that's correct.
That is correct. Yeah, good. Right. Now, so you should remember what do you mean by the box plot. Box plot is explaining middle 50% of the data. Middle 50% of the data can be explained by the box plot. So, what are the important parameters in box plot? Quartiles, Q1, Q2, and Q3. Q1, Q2, and Q3. These are the three quartiles which explain the box plot, right? Right. Right. We cannot talk about now these things. We will continue tomorrow. We will continue from this tomorrow, right? Now, can you tell me